I think last week we've covered all the tropics, Cancer, Capricorn, and northern and southern hemisphere, that kind of stuff, latitude and solar altitude and so on. And the rest will be on your effort. Okay, but it's okay. At the end of the or before the test, my target for the midterm test maybe around week 7 or week 8. Later I will confirm it back, but not in the week 5 or 6 maybe. Whether 7 or 8. Okay, I need to discuss with the Maiden Warriors Jalan also. Okay, I'm going to continue the remaining part of the chapter 2, which is the selection criteria. There's some measurement here that will be used, measuring tools, equipment used for this application related to the solar irradiance and so on. So the first one, until now, I am having difficulty to pronounce this kind of thing. Pyrheliometer, whatever lah. Okay, pyrheliometer for measuring direct radiation. So it's used to measure only direct radiation. Direct radiation. We have learned already the radiation is divided into two. Radiations, the global hourly irradiation or the global radiation is divided into two. One is the diffuse radiation and the direct radiation. For the pyrheliometer is used to measure the direct radiation only. Okay, so the instrument must continuously strike the sun. Okay, that's one thing. The next thing is the solar pathfinder. Unfortunately, because we don't have chance to do the physical class yet, and this kind of things, I mean, this is what we call the solar pathfinder. We call it as the solar pathfinder, and they have the high tech part. High tech version of the solar pathfinder is called as Sun Eye. All the equipments is located in Pekan, in lab, technology lab. We have this kind of measuring. What the important thing of this? The solar pathfinder provide fast, accurate solar site analysis. It is used to do the solar site analysis. In just minutes, the solar pathfinder determines and records year-round site-specific solar data with precision and ease. Again, year-round records year-round. Site-specific solar data, precision and ease. Very useful for studying the shading effect. Shading effect at a particular site. I think maybe you are wondering why only this kind of tripod whatsoever can measure the year-round or specific data. It's actually you are doing the shading study. I mean the shading effect. We are going to, when we do the shading effect, we need to go to the site. This is what we call, it's totally, for me, it's mandatory for the site analysis. Because if most cases, let me be honest with you. For those who graduate and work in a solar company, and they're using the PVC software, and they're doing all the calculation, they suppose which inverter is better, which size, which one is better, and so on. What type inverter, how many in parallel, and things and so on. Then after that, it is necessary for that person to go there, because when we go there, we know the actual situation of the site. From the picture and from the Google map is not enough, because you don't know exactly how tall is the tree. I mean around the region, near to that region. That's why it's very important. Is it any significant building beside or near to that land, or near to that place that we are going to install the solar system? Okay, that's why when we have this kind of solar pathfinder, I think later on I will give you the video related. I think you can Google YouTube also. There's how to use this kind of solar pathfinder. I will paste in the column later. This is what we call, we have the dome, and under that, bukan dome yang tu Fast Furious we have this kind of chart. We call that as the solar pathfinder chart, maybe. So this specific chart is different to each latitude. It is provided by the company lah. By this company, I think they're given you several type of latitude, different latitude of this the solar pathfinder chart. Okay, So uh, if you look from here, there's a line. I mean the vertical one. There will be 12 lines that represents 12 months. Okay, 12 months of the line. Line of the 12 months. Which one is the Monday? No, which one is February? Which one is March? Is totally depend on the latitude. For example, this one for 25 to 31 degree north of latitude. So it is only can be used for this region. For Malaysia, I think they have another one, maybe 0 to 4. I think 0 to 4 because we are located in 2.6, 2.5. So degree knots. So there's different. You need to use the different. The sequence of the months also. I mean, from this line, the vertical line there will be 12, represents 12 months. The sequence also different. It's totally different. Then they're giving you this kind of the solar profile chart. Then what you are going to do? This chart will be placed under the dome. Okay, under the dome. It's actually around here lah. They put there, and then you need to facing depends on our location, facing to the south, something like that. They will teach you. I give you the video, then maybe for you it's easily for you to understand. Then there's a compass here, and then from the dome you are going to see. I think so. It's not really clear. You are going to see the shadow from the nearby trees or nearby buildings. It will what we call that? It will appear like a mirror because the dome looks like a mirror. It's transparent. It's transparent, but no glass. It's glass. Then you can see the reflection. You can see the outer part of the trees. So you are going to draw by yourself. I think using the rubber pen, maybe rubber pen or rubber pencil. Then you draw it like this based on the for example, I just show you maybe let's say we have three here, and then maybe here, and then after that maybe, for example, let's say we have the shaded area here. So you are going to draw it under lah, because there's a hole here, left and right. You can put the rubber pen. I don't know, maybe rubber pen. Then you draw it following the shading that you see by yourself. I mean straight line lah. Any question? Do you understand what I'm saying? What I'm trying to say? Later I give you the video that maybe will explain a bit very more clearer. So from there, for example, if you get this kind of line, means that's the shading. There's shading area, maybe here part or something like this. Maybe this part is shaded area. So once the shaded area, then you are going to deduce, you're going to deduct, because there's line also for horizontal, and it's written 2, 3, 1, 2, 3. We total up in one line, for example, become 100. Okay, I give you the video. Okay, I give you the video. It's very difficult for me to explain using this kind of only the picture and slide. The easiest one, I mean the easiest to understand one is to do the practical, or you see the video of the YouTube. There will be an animation. Okay, I will give you. So this still is used by the several solar company, because this is, for me, is more accurate, because it's for those who do this kind of thing. I think fully engineered. The recent technology, they are using the camera. Okay, they're using the camera. We call it as sun eye. You just put the like that in camera. We have that kind of things. Cost you only 20,000 only. Then it will snap the picture of the sky. That's one thing. Another thing, they're using the GPS. There's a built-in GPS. Then you set up there, then you're going to get this kind of the plotted one automatically. That one is the high-tech one. That one 20,000. This one I think maybe less than 5,000, maybe 3,000 ringgit only. But this one is quite significant. It is also taught in the GCPV course in SEDA, the 7 days course for grid connected. Also, it is taught there. Okay, so this one of the module is to do the shading effect study of the solar site, shading effect at the particular sites for the solar installation. They're teaching you by using this solar pathfinder lah. Okay, alright. Any question? Have you got?
No.
Boleh
No,
faham ke
doktor.
apa saya cakap? Naufal?
Boleh, doktor.
I give you the YouTube. I post in the column. That one with the animation maybe easy to understand. Boleh Zulfikar?
Boleh doktor.
Boleh je. Proceed, let's proceed. We don't have much time. Okay. Next is the UFO. It's not UFO. Looks like UFO. We call it as the pyranometer. I think most of you know that. So this pyranometer is used to measure broadband solar irradiance on a planar surface. It can measure both direct solar irradiance and the diffuse solar irradiance. This is the thing. That's UFO. UFO is the pyranometer. Pyranometer is the UFO one. And then we have the solarimeter or solar irradiant meter or whatever lah. That can measure the watt over square meter. Like the brand C-Watt I show you before. The irradiance is the same thing as the solarimeter, solar irradiant meter, whatever. As soon as it can measure watt over square meter, it's there. Okay, it's the same thing. Then we have the weather station. Usually weather station is the set. They're giving you the value all, temperature, humidity, wind. Wind also, wind speed also can get from here. And then they have also the irradiant meter and so on. It's called weather station. Usually, of course, it's more expensive than the pyranometer only. Okay. But in most cases, I think most governmental station that record the math, I mean the place, the government building that are suit with this kind of weather station in I think under the Meteorology Malaysia, they're using pyranometer lah. And they use pyranometer also to measure the solar irradiance so that it can both measured solar irradiance, diffuse and the direct. Okay. Okay, looks like I'm saying something. Okay. For several slides, we go to the next chapter. Next chapter, maybe we're going seriously to the solar. Okay, other useful, I think you already know. Now, recently, we haven't seen anymore because there will be no temperature checking before you entering the premise. Now no need more. We just scan my sejahtera and finish. But before this, we are playing with this kind of things. Okay, just shoot it on your head. Okay, this is thermometer, infrared thermometer. Depends on the brand, the accuracy and the precision is totally different. If you buy from the internet, online, that costs you maybe maybe 20 ringgit or less than 20 ringgit. You cannot expect the quality and the precision with the Fluke one. Fluke one or Kyoritsu that costs hundreds ringgit, cannot compare lah. Okay. To be honest, if you use the infrared thermometer like we used to play with them before we entering the ECM, KSM and so on. To be honest, to be seriously, it is not accurate. If you realize, you just go anywhere. Most cases, most temperatures, you get 36.4 until 36.9 only. If you realize, I'm not sure lah. Maybe you see different thing. You know that even you close your head and you close your forehead, beep, and you can see and barely to get the value more than 37. If you still remember if you realize that. I think the highest one 37.5 is the higher. It's very rare to see more than that. You know the limit is 37.5, but most cases 37.4 and below lah. And between 36.6 until 37.3. And you will see that seriously. You go anywhere. That's why your temperature is always okay. But if you use the temperature that under your armpit or under your mouth or inside your use the temperature in the clinic from the clinic the inside your ear, you will see that that's the correct one. Even that takes time. You put under your armpit and then you maybe take 1 to 2 minutes to get the temperature. That is the real one. The most accurate temperature to be measured. The place, not using it, but it's okay lah. We just happen. So at least what we call that, at least tak spoil lah mood kita is not spoil kan, our mood's not spoil before we enter the restaurant. Okay, temperature everything is okay, but actually it's not accurate. That's why there's no meaning to scan your temperature. Okay, there's no meaning. Depends on you and depends on your symptom and so on. Sorry, interruption. Boleh okay, Aziz boleh Aziz, faham Aziz hilang umur Aziz. Kena panggil orang. Faham situation that's the what the situation happened before lah. That's why that's not relevant to use that temperature. But this is my personal opinion lah. Jangan post viral pula. Okay, the next thing is the sun eye. Okay, that I told you. There'll be, I think this depends on the brand. There's a different type of the sun eye. So this camera is camera. So this is the electronic versions of the solar pathfinder. Solar pathfinder you need to mark it manually kan. But this one maybe you can set up the GPS. You can snap the picture of the sky and you see the shading. It will appear here. It depends on the brand. This is what we call sun eye. Okay, sun eye. And then we have the magnetic compass. Okay, magnetic compass. Okay, no need to bring the analog compass. You can use your phone. It's for me, it's tolerable lah. It's okay lah. It's okay. But previous one, I mean the old smartphone version, several years back, I think that that's not that accurate. But now they are getting accurate. So I think you can just use the built-in compass or you just download it. They have already, I think already the interference, what we call that, calibration and so on like that. You can use the apps just like that. Same as the inclinometer. Inclinometer also no need to bring this kind of thing. I think you just can also download declinometer, any software, free software that like inclinometer, and then you take that and your phone and you can put in any slab or any angle, it will show you the angle. I will say that it's tolerable as well. Maybe the error may be around 1 to 3 degree only. It's acceptable. For me, it's acceptable. Means if you go to the site, you want to see the what we call the tilting angle, the tilt angle of the module. So you just download the apps and put on the module and you see. I think that value is tolerable. Maybe minus or plus minus 3 degree is the maximum one. Mostly, I think is you can use. Okay, this is usable. Alright. Right. End of chapter 2. Now we'll go to the chapter 3. Sorry, the slides always different to the chapter kan. Biasalah. Okay. Tengoklah mana yang sempat edit, tak sempat edit. Okay. So we are going through to the PV system and components. Okay. This is the first thing that you need to do. This is the first thing that you need to know. The recent technologies or the PV technologies. So technology of PV cell can be classified into 3 generations. I'm giving you just the typical. There will be extravagant of the other types of the technologies of the solar cell. But mostly it is divided into 3 generations. Okay, 3 generation. First generation, second generation, and the third generation. Okay, alright. The first generation is the crystalline silicon cells. What is the crystalline silicon cells? It's currently used everywhere. Okay, monocrystalline. I think you already get used with this kind of name. Monocrystalline, mono silicon, and polycrystalline. Monopoly, monopoly, not the game, the card game, but it's actually monocrystalline and polycrystalline, or we call that poly or mono and so on. What is the mono? So mono is the monocrystalline, the single seed crystal, single direction. Poly is the multiple direction of the wozit. I mean the silicon, the direction of the silicon, the atom of the silicon is different direction. We call it as polycrystalline. But I will teach you the difference between this in physical time. So the first generation, remember, crystalline silicon cells that are massively used in everywhere in the part of this world. Okay, it's used anywhere, everywhere you can see that. That's monocrystalline and polycrystalline, right? So that is the first generation of solar cell. What is the second generation? Thin film solar cells. Thin film solar cells. Okay, what is the thin film solar cells? Is the examples. Amorphous silicon also is a thin film. Cadmium telluride, copper indium selenite, copper indium gallium diselenite, CIGS, CDTE. We cannot see in Malaysia, but we can see, I think, in Germany and so on, in other country, European country, they already use the thin film type of solar cells. Okay, what is the difference between crystalline and thin film? Okay, crystalline is they take the raw material from the silicon and they process. What is the thin film? The concept of thin film is to deposit a film. Deposit a film. In other words, it looks like you have the raw material silicon, for example, but they're not using silicon only, or only amorphous. They melt it. Okay, they melt it, and they melt, I mean, at certain degrees of temperature, high degrees. And then after melting, it open the shutter. It is done in the vacuum chamber. In the vacuum chamber, and they open the shutter, and when it start to boil, not boil up, evaporates. When it reach certain temperature, very melting, total melting, and sometimes it start to evaporate, and there's a ratio there. That evaporate process, there'll be substrate up there. They put it and they start to stuck on the substrate. That's the concept of using the thin film. Okay, the thin film concepts using the evaporator. Okay, amorphous cadmium telluride is that's why they're mixing with the telluride and so on. That's the best concept of the thin film. Compared to the crystalline. Crystalline is not like that. Crystalline, I think the slicing the silicon and process, cleaning, encapsulate, and so on. The process. But thin film, that's the idea of the thin film lah. Thin film deposition technology. Huh? They need the proper chamber, must be vacuumized. It cannot be oxidized there. Oxidized cannot be there. There will be no oxidation. The place that cannot, the place that are not oxidized, it need to be vacuumized. Okay, then because if oxidized, it will react. The oxygen also will react with all the material. Become the oxide layer or become the oxide material, oxide metal. You don't want the oxide metal. It's not oxide metal. It must be totally vacuumized with no oxygen at all. Okay, then start to deposit and you get the cadmium telluride, for example. Okay, the kind of process is quite the manufacturing process level, and also the equipment also, I think, is quite high. Okay, that is the second generation. The third one is the third generation. Third generation able to generate in any light density. I'm summarizing. For the third generation one, call that dye-assisted solar cell. The word that I did. Organic photovoltaic perovskites. Perovskite also with the plumber. There must be the plumber metal there. But what is the? I'm not promoting. What is the advance? What is the advantages of the third generation? It can generate. It is possibly generate the energy in any light density condition. In any light condition, as soon you have the intensity or as soon you have the illuminance, regardless it comes from the lightings, come from the LED bulb, come from the sunlight originally, indoor lighting, it still can absorb energy and produce the current. Even it's not much, it's now rapidly and aggressively aggressively researched by many research teams.
Also cahaya bulan ke Dr.?
Sorry? Cahaya bulan maybe. Yeah. But cahaya bulan, very limited, limited energy. As soon there's energy there, as soon there's the lighting there, it's possible. You can even generate, for example, several hundred millivolts under your room lighting. You're not going yet on outside. I mean, they're under the sunlight, cahaya matahari kan, pencerahan matahari kan. Still not there. Even if you are indoor also can generate. It's possible. Millivolts already come out from there. This is the third generation. What they do, I think I don't. After we're going to have this kind of examples or pictures. You can Google it. The concept is absorptions. The concept of photosynthesis of the. They're using the concept of the leaf, the green leaf, doing the having photosynthesis process through the material component we call it as chlorophyll. So that chlorophyll is, absorb the energy from the sunlight and do the photosynthesis, right? So the same concept with the third generation, that's the solar cell, organic or perovskite. They're using the chemical that imitate the plant, okay, the plants and fruits, leaf, okay, using that things generate energy. To be honest, the generated energy is still at the low level. Still at level because they're still keep increasing. They are increasing the efficiency. They are changing the material and so on. The absorption one. They're using natural. They're using synthetic. Sometimes they're using the synthetic, artificial. To be honest, it's lesser than the monocrystalline. Monocrystalline already established. Severity, it's already 20 to 30 years already. What the crystalline based solar cell, even the company also they're pushing the limits. Okay, they're pushing the limits. They are now pushing the limits, the efficiency of the solar cell based solar modules. Of course, they are stable already, established and stable. You know the problem of do you know what is the we are saying that PV system, PV energy, I think we have discussed before in the first chapter. Solar system is one of the renewable energy, and I mean green and renewable energy. Do you think there's a disadvantage of the PV system? Who knows? There's some disadvantage that now is coming out. It's raised by the certain persons, and people also already know that the PV. I mean the PV system is now start to show their disadvantages. Do you know what is that? Does anyone have
Cost.
idea?
Cost.
Huh?
Expensive.
What?
Expensive.
No. Solar modules now, the price is getting lower and lower and lower and lower.
Makan space.
Makan space? No, you put
Untuk
on the
ground.
roof, there will be no makan space. Like I told you
Untuk
before,
farm punya.
now one single PV module tu, maybe 2 meter to something, already produce 650 watt. So the issue is not the space anymore. The expensive, if you're saying the cost, no, the cost is totally decreasing. Space.
Peningkatan suhu.
What?
Peningkatan suhu.
Peningkatan suhu. Tak menjawab. Tak. Kita tak nampak peningkatan suhu tu. Suhu memang panas pun sekarang. We just finished the equinox. The temperature is getting higher. Who said that? Radioactive? No, not radioactive lah. We are not using uranium or cesium. It's still it's lesser carbon monoxide. Carbon dioxide. It doesn't emit any carbon dioxide. So it's free CO2. No. Ada answer, please.
Quality material.
Quality material.
Quality material.
Quality material.
Pencemaran bahan.
Pencemaran bahan.
Dibuat daripada barang yang tidak sesuai lah.
Barang-barang yang tidak sesuai. Silikon dia pakai. Silikon nak kena habis gunakan silikon. Okay. Siapa lagi jawapan? Siapa? Syuhada Maisara.
Tak ada jawapan, sir.
Any idea? Tak ada?
Tak ada.
Tak ada semua demo ni. Okay. After this class, you Google it. Carbon footprint. It leave carbon footprint. Nanti tengok. Google balik. Carbon footprint. The problem is, kan, the quality and the lifetime of the PV module is given, that they are given by the manufacturer. They said how many years around? Typical? Do you know?
30.
Huh?
30.
30 lama
Dulu,
sangat,
dulu.
advance, 20 years lah. 20 years, they give you 20, 25 years. Sometimes 18 years, 15 years, okay lah. The problem is after that. After 25 years, how we recycle it? What should we do to recycle it? How can we recycle it? Where should we put, take out all the things? That kinds of demolishing or recycling, this kind of things will leave carbon footprints. Not mistaken. So you Google lah, you Google. Nanti kita share balik. Boleh Google lah, carbon footprint. But as a lecturer of solar system, of course we are promoting, but this is true. I cannot cheat you. This the issue that will come is now is starting to become the issue lah. Because after 20 years, what will happen there? Can we recycle it? Can we reuse it back? What should we do? What about all the materials? If we melt it, what will happen? What will leave after that? Aluminium, you can use that. I mean, the frame, you can use the aluminium one. But the module part, the aluminium, the frame, you don't need to worry. Take it out, melt it back, then use it back end. Aluminium kan? Aluminium boleh guna yang tu, yang ada silicon. What should we do? This is true story. Okay. Alright, so organic or PV is the same. So dye-resistant solar cells is the concept of using dye. Organic is using the organic, which is the carbon-based material. Perovskite is the mixture of the organic and dye, and also the plumbum-based material. Okay, saya bagi gambar lah sini. So the monocrystalline, the left side is the monocrystalline, and the right side is the polycrystalline. Can anybody tell me what is the difference between both in physical features? What can you explain from here?
Color. Color.
Color, okay.
Color,
which what color what?
Mono hitam.
Mono blackish lah, blacky lah.
Blacky.
Okay, from here maybe you can know, but in the real situation sometimes it's no different. It looks no different lah sebenarnya. Okay, one color okay lah. Line other than that.
Grid line.
Apa?
Dia punya line, grid line dalam solar panel tu.
Okay, grid line. Lebih spesifik. Please be more specific. Grid line. Okay, lepas tu. Apa yang bezanya? Sebut je.
Corak dia, sir.
Corak. Okay, teruskan. Go on. What corak?
Corak. Mono tu dia macam dia tak square. Kalau crystalline tu dia square.
Okay, boleh lah. Okay. Square shape, polycrystalline looks like more square shape. Yang ini diamond. I'm saying typical case. But recently I see also even the poly also is the same structure with that. But typical way, yang ada diamond or half diamond, most cases I can say that maybe high possibility is monocrystalline. Okay, monocrystalline. Why for me is important for that? Maybe if someone asks you, again, you want to impress somebody, you work together in the site, you see the solar module there, oh, they're using mono, what type of brand? At least you know, if you see this kind of the clear, diamond shape or half diamond, sometimes become like this, dia juga macam ni, ada juga macam ni, and then like this, half diamond, diamond, and you can see the dot, the white dot between the cells. This is cell, ni cells, satu ni cells, kita panggil silicon cells, and it's assembled seriously like that and parallelly, so it become the solar module. So if you see it will clearly see that if you see this kind of things, please be confident that maybe high possibility this is a monocrystalline. Okay, but if you see this, maybe most cases is polycrystalline. Okay, so mean from you're walking to the site and you see the module, they're using the polycrystalline, whatever brand, maybe Yingli or Panasonic, just say like that. So maybe people say at least at the first glance, you know already. I mean the idea, you have the idea. Okay, they're using monocrystalline because they are more efficient than the polycrystalline, for example. Okay, like that. So that is the difference in physical feature of the solar module. Okay. If you say flexible or not flexible, actually I have this is my product. I have 3 modules. Now I'm not using that. I don't know why, because my PSM student, FM student already finished with this kind of PVDO based system. Okay, application. So it remains in my room like that. So I bought 3. Okay, and I have added one, the aluminium frame based solar module also. It is all monocrystalline and it is flexible. It is placed under the what we call that, plastic, something like that. But the cells there is patch. It's placed on that plastic lah. Encapsulation. I'm not sure about the line. Okay, it's not thin film. Again, I restate, this is not the thin film. It's different. It's just the monocrystalline but flexible one. So this is what we call the flexible solar panel. It is useful for the place like it's actually I bought this kind of things. One is for the research, and the one I want to put on my car just to try lah, put the battery. But later I found out another issue kan. Where should I pull in the cable from the roof kan? I bought already flexible. Flexible. You can just use tape on the roof of your car, paste there, impress person, bragging, show off kan. And then the problem is the cable lah. The cable, where should we pull in the cable? Maybe through the window. Oh, it's so what we call that? Ugly lah kan. Not smart lah kan. Nampak selekeh habis masuk
Tebuk atap kan.
tebuk atap tu lagi leakage. Kau jangan macam-macam. Shot habis saya kata. Saya fikir tebuk atap agak letak sealant kan. Some sealant something like that, but still worry lah. Once the water is in.
Tapi bukan ke EV car dah ada solar panel atas-atas?
EV car memang. Saya sekarang contohnya pakai kereta lama. Contoh aku pakai Azia, letak kat Azia kan. Poyo lah orang tengok kan. Tapi nampak macam macam mamak ni mamak solar gitu.
Boleh sir.
Try lah. Tebuk.
Doktor, harga ni dalam lingkungan berapa?
Okay.
Satu PV panel.
Ya, kau nak beli I bought this kind of things, 100 watt, 100 watt. At that time, several years before, 375 something. F-LAN, the nama tak kisahlah apa, whatever lah. It's still made in China, but 300, I think now reducing lagi lah. Ni 300 saya beli ni beberapa tahun. I think 2018 I bought this. Now, 2022 kan. 4 years already. Ni 100 watt lah. Saya beli 100 watt.
Apa beza single silicon seed crystal dengan random orientation crystal tu?
Tu. Dia detail lah sebenarnya. Aku pun tak erti sangat. Silicon punya seed tu, dia kena study on the atom tu. Dia punya wozid, kita panggil wozid. Aku nak sebut pun aku tak erti lah. Dia ada bulat-bulat tu kan. Aku pun tak apa tahu lah dalam tu. That's a direction of that. Atom dalam tu. Orientation of crystal in the silicon seed tu. So the direction is in the same direction. One direction is called monocrystalline, but it's the random orientation like that. It's poly. I don't know detail seriously. Google lah. Tapi kita panggil ni, if I'm not mistaken, wozid. Saya pun tak pasti lah. Dulu punya belajar masa degree. Wozid apa benda lah. Tahu lah. If you ask other than that question, if you ask question other than that, I can answer. For me, it's not important in the study kan. Tak ada relate pun dengan ni. Whatever lah. We as the manufacturer or the engineer, we know, okay, poly and mono is enough. Then give quotation to customer, client, finish. Get your commission. Okay? Boleh, Naufal?
Boleh doktor.
Okay, jangan risau. Client will not ask this kind of things. People are using monocrystalline because of the high efficiency. If compare the same brand, the same process, for example, brand Shahiman, brand Iman mono and Iman poly. Iman mono will be better than the Iman poly.
More efficient and more expensive.
Slightly expensive lah.
Okay.
Mean if you compare Iman to Iman brand, Iman mono, Iman poly. But if you compare Iman mono and Panasonic poly, we're not sure yet. Maybe the efficiency of Panasonic is much more better than me. because I did it in my house kan with my cats. So that difficult kan. Cannot control the high efficiency, you cannot push. Lepas tu banyak pakai manual kan. Mungkin susah. Tapi brand yang Yingli, brand good, the good one, anything Kyocera, something like that, Panasonic, they are much more better. Sun Power, of course, they are more quality than the Iman Mono lah. That's why it's quite subjective. If you compare mono to mono, different brands, sometimes that one's much cheaper. That's why the work of the solar, what we call the engineer who doing the design, they're using that kind of PVC. They're using the the efficiency cost because it's different. Even efficiency same also, different brand different. Brand Iman and Panasonic, efficiency is the same. People are going trust more on the, of course lah, trust more than brand Iman lah, of course lah kan. Mesti pergi Panasonic kan, contoh. Subjektif. Tapi if we compare same brand, mono much efficient lah. Okay.
Doktor ada soalan.
Yes.
Kalau macam mana pula kalau dengan type yang passivated emitter and rear cell PERC panels?
Kau susah itu ni. Ulang ni. Passivated
Aha.
Ulang ni. Passivated
emitter and rear cell PERC panels.
I think that the one third generation lah. Emitter
Oh
generation.
ya.
Passivated emitter. Payah masalah ni. Rear cell lah. Looks like the third generation lah. Not sure. Tak tahu. Ataupun second generation thin film. Mungkin ada. Dia ada lagi. There are more. Who are very with different name also. That one seriously. I just give you a very typical. Okay. Maybe thin film. Maybe. Or is under the cluster of the third generation one. Passivated emitter ni aku tak study ni. PRC. Okay. That's my answer. Boleh Ashraf?
Okay, boleh dah.
Okay. Next, Emma first. No crystalline silicon. Cadmium telluride. Okay, CDT solar cell in ni I just get from the internet. German. They're using already 300 kilowatt park. And it's the cadmium and Te base. Okay. Copper indium selenide CIS is the copper indium selenide base, and it's also flexible. It's more flexible because the thin film. Maybe I think it looks like the paper. This one also looks like paper because the concept is deposit the material. Okay, deposit the material, and then they write the cathode and anode and so on. But first of all, the process is the concept is melting. Then you melt it in the vacuum under vacuum chamber. And you put there. That one is second generation. The third generation one looks like this. That's color based material base. Colored material base. We call it dye. Any dye, any coloring that may come from the chlorophyll base, anthocyanin, fruits, plants, green plants, leaf, and so on. That is the dye synthesized solar cell. Yeah, they have glass of course, and then they put there. It doesn't, what you call that? For the case of their synthesized, even you're not facing directly to the sun, also it still can attract more energy, and still it's better. Even under very low light condition also can generate, but the voltage is lesser lah, of course lah, but still can generate. If you use the silicon based solar cell, maybe under in your room is barely generated. Maybe the voltage will drop totally. There's still voltage but very very low. Okay, significant are the drops if you use under.
Ni dah available in market ke Doktor?
Apa dia?
Dah available in market ke?
I think Malaysia not yet. In Japan, in other country, they already fabricated one, but I'm not sure. Japan, I know they using that. I think still there's some research regarding that. Still we are doing. I think Malaysia not yet. Malaysia maybe even we have some power also poly poly mostly. Because the dye we can get from the material, I mean the natural dye also, not only artificial or synthetic. Artificial is much expensive, but people are using, for example, waste from the plants, the green plants. Like I told you, we are the first one, pineapple waste ke, palm base ke, all the waste that coming from the plants, plantation. We are not talking about your kebun. We are talking the high scale, the big scale. Felda base punya yang daun hijau tu, that one we use as the mass material, raw material, process it, take out the liquid, I mean the chlorophyll from there, and we do the fabrication of DSSC, for example. It can be more renewable lah compared to silicon one. Even silicon is not finished, haven't finished yet, but still there is the silicon. You know, silicon and chemical play with chemical process, but the dye one you just get from the waste. It's natural, like that. Then organic is carbon base, okay, carbon base, and perovskite, plumbum. They have plumbum and chloride base, organic base. So compared to the dye, DSSC ni, perovskite, they must have plumbum. They have the plumbum layer there. For those who are doing, who have interest in this kind of study, they have a lot of papers regarding that. People are only focused for the perovskite, also a lot of papers, okay, journals. I only have 5 minutes, okay. Okay, PV cell characteristic is the single line diode model, okay. Is the equivalent circuit, PV cell of the equivalent circuit diagram, blah blah blah, junction, and this is the light generator current. We have the diode current, shunt current. So this shunt current, this is series resistor, and we have the voltage across the cell. So this is the basic, just the basic PV cell equivalent circuit. Maybe it's going to relate. You're going, for example, doing lab. Maybe this kind of lab will play with this circuit and use a different software. Okay. If you want to know that, no detail, then you can Google lah. Basically, for the PV cell equivalent circuit, we're using the single line diode model. Okay, single line diode model. 5 minutes. Okay. This, okay, after we know already the solar cell and so on, PV. There's another thing that at least you know this kind of thing. This is the basic characteristic of PV cell or photovoltaic cell or photovoltaic module. Okay. The IV curve of the solar system, IV curve of the photovoltaic cell, where, okay, the plot between current versus resistance, because it's originally coming from the single line diode model. You can study, you can Google in YouTube also, how come this kind of curve coming out. Okay, you need it's originally coming from the Schottky-Berry base, the single line diode model. You know lah, tahu single line diode model kan macam ni kan, diode. So ni ada V on dan sebagainya. So this is the V, this is the I. So this is the single line diode model. But to become this kind of curve, there's a method, there's understanding why it become like that. So you can Google it. Okay. So, but the important thing is the characteristic that we characterize for the PV cell is this thing. Okay. This is the IV curve. So this is the IV curve. And from IV curve, you can produce this kind of PV curve lah. PV. P is the P equals to VI. Okay. Okay, simply plot, just multiply P with V with I. So power is 0 watts when either I or V are 0, means that when the I is what we call that? The I is maximum when the voltage is 0. The voltage is maximum when the current is 0. So these two places is the critical role. So maximum power is produced when V equals VMP, at which point the current is IMP. For those who are doing study regarding the MPPT, maximum power point tracking, okay, we are talking about these things. Okay, we are talking about the tracking to the maximum one. For those who are doing the solar tracker also, it's the same idea here. It's not we get the maximum of the voltage. The maximum of the voltage is the open circuit voltage where the current is 0. But actually the value where the total up of P equal to IVI is the maximum. This is what we call maximum power or PMP. That maximum power point tracking, I repeat, is not the VOC or the IC value. It's the VMP and the IMP values. So in order to track to the maximum one, there's a lot of methodologies, maybe come from the perturb and observation, and some algorithm are used. Okay, in order to drive the system to the maximum power. Okay. Any question? I have only 2 minutes left.
No.
I mean the IV curve is that this the IV curve for the PV is this. For those who didn't study with that, if you don't get this kind of curvy, the smooth curvy circuit, so there will be problem in your setting and so on. Okay, this is the ideal curve of the IV curve for the PV. Okay, so the item here again, VOC is the maximum where I0, IC is the I maximum where V0, IMP and VMP is the value where the total up or the what we call dot product of the IMP VMP showing the maximum value. So this is the PMP. So this is the what we call the maximum power lah. Where the IMP multiply with VMP. Apa lagi? Good. Okay, guys, last. Okay, after get the PV, for those who are doing PV studies, and then there will be a very common parameter, we call it a fill factor, where fill factor is the PMP over IC multiplied with VOC. Typical value of fill factor, okay, is between 0.6 to 0.7 lah. The fill factor. But if we're playing with the higher fill factor, you need to compare to the study lah. I mean, compare to the paper or journals that are published. Okay. Sometimes they are looking for the nearly one. Okay, nearly one. Means that the maximum, the IMP is pushed to the maximum. Okay. And then the next is the conversion efficiency, the efficiency of the modules. Okay, it's totally P out over P in, where the P out is the PMP. Okay, the value of P out can be get from the PMP. We're going to the corrected and STC, that's a different story. We'll go there later. Over G is the solar irradiance, instantaneous solar irradiance. Multiply with A is the active area of the cell. Active area of the cell. Okay. Area of the cell, the size. For example, module 1.8 multiply with 1.1 meter. So that is the active area of the cell. So from here, the IMP is coming from here also. It's the same thing with fill factor here lah. I mean, there will be no IMP and VMP. If you get the IC and VOC, then you can get the efficiency of the module. Okay, but the area is fixed. The irradiance must be fixed also lah. Then you can get the instantaneous efficiency. It's totally different on the irradiance. If irradiance higher, if getting higher. If the irradiance is getting higher, is it better or not? You cannot say anything because it totally depends on the PMP. So that's always changing, the efficiency. But you can get I think there's some value, what we call it, rough value or the typical value. Okay, for that depends on the module. That's why this is what people do characterize. They fabricate solar cell, and then this is the thing that they want to fight. This is the thing that they want to show off to the other people in the world who are doing the same research. How much is the efficiency? The higher is the better lah. The higher is the better. Okay. That's all for me. I need to go rush to meeting. Any question? Any question?
No.
No, sir.
Saya tanya 2-3 orang. Fatin, Adawiyah, any question?
No, sir.
No. Syahmi Hafiz, any question?
No, sir.
Okay. So if no question, as usual, I will upload the video, but later lah, sometimes takes time. And this Wednesday, no class because I'm going outstation. So any updates, I will inform you in the WhatsApp. Okay, so see you on Monday. Alright, thank you.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.